Hello everyone, in this video we will solve a JEE Mains previous year question based on the matrices. Let us carefully understand the problem and learn how to approach this type of question. This question was asked in January 2026 session. Let's get started. Let us first carefully observe the problem. In question, it is given that A and B are two matrices of order 2 by 2 and this condition is hold. Then the sum of all element of B power 100. So from this relation we want to find B, then we sum the all element of B power 100. So given that A is equal to 3 minus 4 1 minus 1 and we need A power 100. So in this case we want to see the patterns of A's power. So A is given, so next we find A square, so that is 3 minus 4 1 minus 1 multiply by same matrix 3 minus 4 1 minus 1. So that is equal to 5 minus 8 2 minus 3. The next we want to find the A cube, that is A square multiply by A, that is A square. Previously got 5 minus 8 2 minus 3 multiply by matrix A 3 minus 4 1 minus 1. If we multiply this, then we get 7 minus 12 3 minus 5. So if you see the patterns of A powers, that is A square, A cube, you see one beautiful patterns. So that is 3 minus 4 1 minus 1. Second matrix we got 5 minus 8 2 minus 3. Third matrix we got 7 minus 12 3 minus 5. If you see this part, suppose if you focus this element, first element, that is 3, that is 5, that is 7. So if you see the patterns are this patterns, that is 3, we can write that is the 3 5 7, that is the odd number we can write the 2 and plus 1. So that is, if you write this 2.1 plus 1, that is 2.2 plus 1, that is 2.3 plus 1, that is 2 dot this value, this power value. So that is 2 and plus 1 type, and this element minus 4 minus 8 minus 12, we can write is minus of 4.1, that is minus 4.2, that is minus 4.3, and third element 1 2 3, same as 1 this 2 this 3, so we can write is 1 2 3, and fourth element is minus 1 minus 3 minus 5, so odd number decrease by minus 2, so we can write is minus 2.1 plus 1 minus 2.2 plus 1 minus 2.3 plus 1. So we got these patterns, so we can easily write from here A power n. So A power n is equal to 2n plus 1 minus 4n, that is n, that is minus 2n plus 1. So if we multiply in this way, you see the pattern of A power n. So we want to check just A square and A cube, then we see the a beautiful pattern of A power n. So we got A power n is equal to this. So therefore A power n is equal to 2n plus 1 minus 4n n minus 2n plus 1 for all n. Now we need A power 100. So we just put the value of n is equal to 100, that is 201 minus 400, that is 100, that is minus 199. In a given that this relation A power 100 is equal to 100 times B plus I, that is identity matrix. So we put here A power 100 is equal to 100B plus identity. From here we put the value of A power 100. So this implies 100B is equal to A power 100 minus identity matrix. Therefore 100B is equal to put the value of A power 100, that is 201 minus 400 100 minus 199 minus identity matrix 2 cross 2, that is 1001. Therefore subtract it, that is 200 minus 400, 100 minus 200, so that is 100b. This implies b is equal to 2 minus 4, 1 minus 2. Next we see the b power 100, because we need all sum of element of b power 100. And question asked sum of all element of b power 100. We got just b is equal to this matrix. So now we want to check the patterns of b power. So we need this. So b is equal to, we have 2 minus 4, 1 minus 2. Next we check b square, 1 minus, multiply by same matrix, 2 minus 4, 1 minus 2. So if we multiply and check it, that is actually 0, 0, 0, 0. So b square is equal to, we got 0. So if we multiply b cube is equal to b square dot b, that is equal to 0. So in this case, if that value is any higher power, we get is equal to 0, 0, 0, because b square is equal to 0. Any multiplication of the b square is equal to 0. So sum of all elements of b power 100 is equal to 0 plus 0 plus 0 plus 0 is equal to 0. Therefore sum of element of b power 100 is equal to 0. This is the answer. So overall the question we just doing a, we have, that is 3 minus 4, 1 minus 1. From this we just see the patterns of a square, a cube. From this pattern we got a power, that is 2n plus 1 minus 4n, n minus 2n plus 1. From this we find a power 100 and put this equation, a power 100 is equal to 100 times b plus I. Putting this value of a power 100 and identity matrix, we got b is equal to 2 minus 4, 1 minus 2. From this we see b square is equal to, we got the 0 matrix. We got the 0 matrix, then any power of b greater than 2 is 0, because a power 100 involve the b square into b power 98. So that is 0 matrix. Any 0 matrix multiplied by any matrix is equal to always get the 0 matrix. So b power 100 is equal to 0 matrix. So sum of element of b power 100 is equal to 0 plus 0 plus 0 plus 0. So 0 plus 0 plus 0 plus 0 is equal to 0. Therefore sum of all element of b power 100 is equal to 0. So this is the final answer.